All right, so you know that x is 90 because the diagonals of a kite are perpendicular. You know that y is 42 because this is going to give you a little triangle right here, and that has to be 42 degrees. Then to figure out what z is, if you know that this is 75, what's this up here?
75.
Also 75, and since this is 90 right there, that means that z has to be 15. And then finally, m is the length of that segment there, so it is also going to be 8 centimeters. All right, so that was 4 points for that problem because there were 4 questions. Okay, pretty much the same question on form B. The numbers were changed only slightly. So once again, x is 90 degrees because the diagonals of a kite are perpendicular. The length of w is 4 centimeters because that diagonal is bisected by the other one. Y in this case is going to be, what, 39? Yes, because 51 and 39 make 90 plus 90 makes 180. And z will be 18 because 18 and 72 and 90 also make 180. So are there any questions on problem number 1 from either Form A or Form B? Okay, let's go back and look at number 2. So number 2, they tell you this is a kite. So you know that if this is 14, what's K?
14.
Also 14. Then if this is 73, what's Y? 73. And what do these 4 angles have to add up to? 360 degrees because it's a quadrilateral, so that means that x is 63 degrees. Okay. All right, same thing on the other quiz form. Yep, I will in just a second. So for this one, what's W?
9.
9, because it's a kite, so those sides are the same. What is Y? 75, because this angle and this angle are congruent. And since this angle, and this angle have to add up to 360 degrees, x is 62. Okay. Justin, you want me to go back?
Yeah.
Okay, any questions on problem number 2 from either quiz form? Okay. All right, let's take a look at number 3. So now we have an isosceles trapezoid. So we learned a couple things about the angles in an isosceles trapezoid. One thing is that we learned is that the pairs of base angles are congruent. So if this is 121, what's Y? 121. And then we also learned there's a relationship between the angles that are in between the parallel sides. What is that relationship? They add up to 180. So if this is 121, 180 minus 121 is 59 degrees. Okay? Same thing on form B. What is Y going to be? 119. And then since x and y have to add up to 180, if y is 119, then x must be 61. All right, any questions on number 3? All right, let's go back to number 4 on the first form. So now we have an isosceles trapezoid. So if this right here is x, what's this over here? X. So give me an expression for the perimeter of this isosceles trapezoid. Yes?
105 equals 2x plus 53.
105 equals 2x plus 53. Does that make sense?
Yeah.
Because you know the perimeter is going to be this x plus this x, which is 2 x's. 23 and 30 makes 53, and that has to equal 105. So now if I just solve that for x, subtract 53 from both sides. So 52 equals 2x, so x has to be 26 centimeters. Make sense? Justin, you got it? Okay. Okay, and then number 4 on the other form was the same deal. Somebody else besides Blake give me an expression or an equation that I could write from the perimeter of that. Yeah. 111 equals 53 plus 2x. Okay. So to solve this, just like in the other one, I subtract 53 from both sides. What's 111 minus 53? 58. Okay, so this time 58 equals 2x, so x equals 29. Okay, any questions on number 4? Nope? All right, let's take a look at number 5. Okay, so now we're into the mid-segments that we learned about. What's true about these two lines? They're parallel. Okay, so that means if this angle is 60 degrees, what's this angle here? 60 degrees, because those are corresponding angles, so they are congruent. If this angle is 40, what's this angle here? 140, because the ones in between the two parallel lines are going to add up to 180. And then if this is 26, Z is 13, because one of the things we learned is that the midsegment of a triangle is half the length of the third side. Okay? Silly mistake there, Justin? Yeah?
Y equals 40 degrees, Z equals 1.
Oh, okay. All right, so then on form B, again, since this line is parallel to this line, X will be 40 degrees because those are corresponding angles, so they are congruent. Y will be 120 because they add up to 180 degrees. And Z is 26 because it's twice as much as the segment in the middle, as the mid-segment. All right? Okay, and then the last one. Now we're looking at the mid-segment of a trapezoid, so this is a little tricky. This thing right here, what's the relationship between this mid-segment and these two sides?
Add
Add them together and divide by 2, then I'll get this one right here. So what number divided by 2 is 24? 48. So these two sides have to add up to 48. So if one of them is 13, what's the other one have to be? 35. And then same thing with this guy right here. What number divided by 2 gives me 16? 32. So if this is 22, this one has to be 10. Okay? All right, so that is what was going on with the width. All right? Okay, so go ahead and get your assignments out, and let's go over your questions from that. Okay, what do you want?
9 through 13.
9 through 13?
10, 11, and 13.
9, 10, 11, and 13?
Yeah.
Okay, yes, when we were playing with the iPads yesterday, we were able to, because I'm going to play it for, I'm going to be gone 6. All right, we did not, we did not talk about vector diagrams when we were playing with the iPads yesterday, okay? So let's do that real quick. The way vector diagrams relate to parallelograms is in this situation here, you have a helicopter that is trying to fly this way, but the wind is also at the same time pushing it that way, okay? So can you kind of see in your head that the helicopter is going to end up flying somewhere in between those two things? Okay, because it's pointing that way, but it's getting blown this way. Okay, the way you find the direction which it will go is you take and make a parallelogram using the vectors, the arrows that they've given you already. So if I copy this vector right there and stick that vector, hello, where are you? There you are. Okay, can I not? Nope, I can't. So if I copy that vector right there, nope, I can't do that either, and put it on the end of this one right here, okay? And then is that close enough? And then I take this vector right there and copy it onto that one right there. Okay, never mind. Okay, too bad, good enough for government work. Then the way I find where the helicopter will end up going is by drawing the diagonal of that parallelogram, okay? And so this is the, what's called the resultant vector.
Can you use bisect that and get the...
Can you just what?
Can you use
Bisect the angle?
Yeah.
Okay, so Manuel is proposing a conjecture, and that is that the diagonals of a parallelogram bisect the angles. And so he's saying we could just find the angle bisector here and be good to go. Let's test his conjecture and see if... Yeah, we could do this on the iPad, but it would take more time to pass that out than it's worth. Okay, let me just do this real quick. So I'm going to make a little parallelogram right here. Okay, and then Manuel is saying that if I draw in this, I do not know what just happened there. If I draw in this diagonal, then that will bisect this angle right here. Do you think he's correct?
No.
Haley says sure. Kale says no. Guys in the back aren't paying attention. Pay attention. All right, so I'm going to measure this angle right here. And I get 83.26 degrees. And then I'm going to measure this angle over here. And survey says?
Yes.
No. Okay. Unfortunately, not even close. Okay. There is a special kind of parallelogram where that happens. Okay. Yes.
You did like, aren't you when you measure them, aren't you supposed to like measure them in the same order?
If I measure A, B, C, then that's H. Then that's me measuring this angle right here. That's angle ABC, okay? So that's that one. And then if I measure CBD, then that will give me this angle right there.
Oh.
Okay? So those are the two angles that we were looking for. So unfortunately, no, they don't. The diagonals of a parallelogram do not bisect the angles, okay? But it does sort of seem like that might be the case. And so that's a common misconception. So I'm glad that you brought that up, okay? So you do actually have to draw the parallelogram, all right? So same deal, I'm guessing, yeah, for number 10. So this time we have a boat that is trying to go this direction, but it's being pushed by the current down the river. So it will end up going somewhere in between those two things. So once again, to figure out where, I need to draw in, I need to copy this vector right here over to there, and then I need to copy that vector there to there. Is that better? Did I do better that time, Gail? A little bit? Okay. And then the direction of travel that my boat will actually go on would be the diagonal of that parallelogram, so we'll end up going in the purple dotted line direction. Okay? It's not perfectly even, no, and that's okay.
Doesn't speed involved?
Yeah, so that's a great question. So Kale says, and we're getting into a little bit of physics here that we don't need to get in too deep, but what the speed dictates is the length of this arrow, okay? So if the boat were going faster, then this arrow would be longer, okay? So maybe let's say it would stick out like that. That would change our parallelogram to be more this kind of shape. And then in that case, you can see that the boat will end up going more in the direction that it's trying to travel. Okay? So the size of the vector represents the speed of the object. And so the reason why this boat is really struggling to get upriver is because how do the speeds of the current and the speed of the boat compare? The current's going way faster. The current looks like it's probably twice as much as the speed of the boat. Okay, so So they're going to have to gun it a little bit.
Go faster.
Or they could change their angle also, and that would help them too.
Yeah,
Okay?
or you could go faster.
Or it can go faster, yeah.
Yeah.
All right, what else?
11.
11?
13.
11 and 13. All right, so we played with some of these yesterday for the first time. So here's a little parallelogram, and we were supposed to find the missing coordinates, okay? Well, the y coordinate should be easy. What's the y coordinate? C, because this point right here is the same distance above the y-axis as this point right here. Okay, so that means that's going to be
I thought we
C.
were supposed to actually like find numbers.
Oh, no, you're going to use letters.
That's what
okay?
I thought. That,
Okay,
I
but-
just said it, I'm like,
Okay, all right, calm down. Calm down. You're just going to use letters, but you have to use letters that they have already given you. So you can't just make up and start throwing in new letters here, okay? So for our x coordinate here, we need to find out what this distance would be right there, okay? How does that distance compare to another distance on the diagram? Same as from here to here, right? Okay, well, how do you find this distance? How far is it all the way from the origin to here?
One letter apart.
How far? What letter gives me this distance? No, look on the diagram. What letter gives me this distance? It's up there already. First of all, is this an x direction or a y direction? It's an x direction. So which one of these points, A, R, P, or M, tells me how far this distance would be? B. Okay, because this distance, this point right here, its x coordinate is this far away from the y-axis. Okay, so this whole distance would be B. Okay, what is this distance right here? A. So what would I do with B and A to get this little piece that I want? Subtract them. Do I go A minus B or B minus A? B minus A. So the x coordinate of this point here is going to be B minus A. So the coordinates of point M would be B minus A, comma, C. Okay? So the reason why they're asking you these questions is just for you to sort of recognize some of the relationships that these shapes have. The main one being that this one is the same distance as that, but then there's also a relationship between the x coordinates as well. Okay? Anything else? 13. All right, so we got a little flow chart proof to fill in here. Okay, so we know that lean is a parallelogram. Get it? It's leaning. Yeah, okay, all right. A little math humor. All right, so number one says lean is a parallelogram, and then we have to give the reason why we know that. Why do we know that? It's given, good. So this is given. All right, then it says EA, this side right here, is parallel to LN. How do we know that? Nope.
It shows.
But what is it about a parallelogram that lets us know that? That's the definition of a parallelogram, is that the opposite sides are parallel, okay? So this right here is definition of parallelogram. All right? Okay, so then from that we are able to say that angle AEN, so this guy right here, is congruent to LNE by the alternate interior angle conjecture. Okay? What other two angles can we say are congruent by the alternate interior angle conjecture? If we know that these two lines are parallel. Manuel?
L-A-N.
Okay, LAN we're going to get in a minute, but LAN is up against this side here and that side there. So we need another angle that's touching this side and this side. Okay? Anybody? Yes? ALN, good. So that would be this one down here is going to be congruent to which one up here somewhere? LAE, this guy right here. Okay, so what did you say? ALN is congruent to angle LAE. And again, that is by the alternate interior angle conjecture. Okay? All right, notice the arrows here are trying to help you. It's a flow chart. And so another thing that we know, because we know that lean is a parallelogram, is something about the opposite sides. What's true about the opposite sides of a parallelogram? They're congruent, okay? So what are two sides that we would like to say are congruent here that will help us in our quest to prove something? What? Okay, but notice that these two angles, you're right that EL and AN are congruent, but these two angles that they have given us so far are inside of this triangle right here and this triangle right here. So we're trying to show something about those two triangles. What two sides do we want? EA and LN. Good. So we know that EA is congruent to LN. Okay? Therefore, we can now say, name the blue triangle on top somehow. The blue triangle on top. Eat. It's almost lunchtime. So triangle EAT is congruent to, now you have to name the triangle on the bottom in a corresponding way. So what angle on the bottom corresponds with angle E? N. Because these are alternate interior angles. So E goes with N. So it's going to be triangle N. A goes with L. And then T goes with T. So now we know that those two blue triangles are congruent by angle, side, angle. Because again, we said that this and that are congruent. Therefore, we know that ET, this little guy right here, is congruent to TN by CPCTC. We also know what's true about this side and this side. They're also congruent, so we can say that side LT is congruent to side AT by CPCTC. Okay? And then that leads us to the thing that we were trying to show, which was the last conjecture that we discovered yesterday, which is that the diagonals of a parallelogram bisect each other. Okay? So the last thing we would write is always what we're trying to prove in the first place. And in this case, that's that segment EN and segment LA bisect each other. All right? So when we were playing around on the iPads yesterday and we were coming up with those conjectures, you sort of discovered that this was true, but we didn't prove it. Just because we made some measurements on a fancy computer device and it looked like it was the case doesn't mean that it was true. But now we have a step-by-step deductive reasoning proof, so now we know that it is true. Okay, Laura? 16? Yes, we can. All right, 16. Okay, so we want to calculate the measure of each lettered angle. So angle A is inside how many sided shape? Six-sided shape. So if we have 6 sides, how many triangles do we get? 4 triangles. How many degrees is each triangle? 180. So 4 times 180 means that the angles inside there will add up to 720 degrees. Okay? If there are 1, 2, 3, 4, 5, 6 of those angles, how many degrees will each angle be? In other words, what is 720 degrees divided by 6? What did you say, Manuel? 120. So that means that angle A is 120 degrees. Okay? Now, angle C is an easy. Oh, let's do B first. How many sides do we have? 5. There. Okay, so now we have 5 sides. How many triangles does that give us? 3 triangles. Each one of those triangles is still 180 degrees. So 3 times 180 is 540 degrees. So all 5 of those angles add up to 540 degrees, which means how do we find how many degrees each individual one is? Divide by 5. So that means that each one of these angles, including angle B, is 108. Okay? C is super duper easy. So that's going to be 90. And then what's true about these 4 angles right there?
They're gonna add up to 180.
They're going to add up to 360. So if I go 360 minus 120 minus 108 minus 198, I mean minus 90, sorry, 42 degrees for this guy right here. Okay? And then to find E, what will these 2 base angles of this isosceles triangle add up to? 138, because you know altogether you're going to get 180. And so since they're both the same, 138 divided by 2 is 69 degrees. So angle E is 69 degrees. Okay? 18?
Yeah.
Yeah.
Everybody get that before I go on?
Yeah.
All right, number 18. Okay. Number 18 says, what is the measure of each angle in the isosceles trapezoid face of a voiture in this 15-stone arch? All right. If there are 15 stones in this arch, if I were to continue around and make that a whole shape, how many sides would this entire shape have? 30. Okay, so 30 sides means how many triangles? 28 triangles. Okay, Manuel, you got my back here?
Yeah.
All right, so 180 degrees for each one of those. Each one of those triangles means that those angles are going to add up to
Is that it right here? 5,000.
5,040 degrees. Okay? How do I figure out how many degrees each individual angle is? Divide it by 30. So 5,040 divided by 30 is what? 168 even?
Yeah.
Okay, awesome. So that means that this little angle right here is 168 degrees. Okay? So how many degrees would these 2 angles opposite that be? Well, you know they're going to add up to 360. So if I go 360 minus 168, then that means that these 2 angles have to add up to, what is that, 192? Right, and then this angle and this angle are going to be the same. So divide that by 2, and that tells me that these angles right here are going to be 96. Okay? All right, and then we actually inadvertently found out what A is, because this outside shape would also be a 30-sided shape. So that means each one of these whole angles is how many degrees? 100 and, nope, we just figured it out. 168. And so this angle right here is going to be half of that whole angle, so that would be 84. And you know that that makes sense, because we learned that the angles in between the bases of a trapezoid should add up to 180 in those 2 groups. Okay? So we can have confidence that we did that right.
Yes.
All right? Okay, will you pass those forward, please?
17, no, wait.
Oh, 17?
Yeah.
Okay.
Well, that's 19.
That's 19, going the wrong direction. All right. Okay, let's find X and Y. Anybody have any ideas? Manuel?
For X, we use 180 minus 78.
Okay, so this one is 78. This is a trapezoid. So you know that these 2 are going to add up to 180. So this right here is going to be 102.
And the 154 is across the...
Okay, this shape right here is a kite. And so we know that the non-vertex angles of a kite are congruent. So that means this angle here is going to be 154. Okay, so those add up to 256. Altogether, those will make 360. So if I subtract that from 360, I will get 104 for X.
And
Okay.
the bottom row are the same. 102, same thing as...
Okay, so if this is 102, then this is also 102. All right, love it. If this is 160, then this is also 160. Okay, So 102 and 160 make 262. So if I go 360 minus 262, then this time this one's going to be 98 degrees. So x is 104 and y is 98. All right?
All right.
All right, now can we pass it forward, Jill?
Yeah.
Okay, did you want to send any messages to Mr. Raines or anybody in 6th period?
Hi,
Hi,
Hannah.
Mr. Raines.
Hi, people.
Okay, so we are going to do just a quick little review of your algebra skills. Okay, Austin? Austin? They're a day behind you.
Why don't we take a day off?
We're going to get like 14 days off pretty soon. So. Okay, so we have kind of worked our way through this chapter, reviewing your algebra skills as we go. And one of the things that we've done is finding the slope of 2 points. Okay, and so today we're going to use that to come up with an equation for a line. Okay, so what is the form of the equation of a line that you know and love? Y equals mx plus b. And so that is the equation that we're going to use today. In that case, what is the m? What does that stand for? Slope. And what does the b stand for? The y-intercept. Okay, so that is where that's where it crosses the y-axis. Okay. So all you need to do to find an equation for a line is come up with those two things, substitute them back into that equation, and you are done. Right, and then remember that we have slope in two different ways. The way that you learned slope when you were little was that it was rise over run, and then when you got to algebra or pre-algebra or something, you got a formula for that, which was y2 minus y1 over x2 minus x1. And that is what we've been using quite a bit in this class, okay? But for this one over here, they have it drawn out for us. What's the rise? 3. And what is the run? 4. So that means the slope of this line is 3/4, okay? Where does this line cross the y-axis? -2 right here. Okay, there's the y-axis. It crosses at -2. So if my y-intercept is -2 and my slope is 3/4, the equation for this line is y equals, nope, 3/4x minus 2. Or you could say plus a -2. Okay, and that would be fine also. So all you need to do is put the slope in front of the x, and then add on to that at the end the y-intercept. Okay? Laura, you with me? Yeah. All right. So now if they give us a couple of points, we need to do that same thing again, but this time we don't know what the rise and the run are. So we're going to use the formula for slope. Okay? What is y2? What is the y-coordinate of the second point? That's the y-coordinate of the first point. What's the y-coordinate of the second point? 3. I'm looking up here. Okay. The y-coordinate of the second point is 3 minus the y-coordinate of the first point is 6. The x-coordinate of the second point is -2, and the x-coordinate of the first point is 4. So 3 take away 6 is -3. -2 minus 4 is -6, and that reduces to 1/2. Okay. So my slope is 1/2. What's the y-intercept? Where does it cross the y-axis? Tanner? It crosses the y-axis right there at what? 1, 2, 3, 4. Okay, so what is my equation for that line? Plus 4, where it crosses the y-axis. Okay? All right? So find the slope, find the y-intercept, and you are good. Okay? Now, sometimes you're going to be asked to use some of the things that we learned earlier in this class. So this says find the equation of the perpendicular bisector of the segment with endpoints 2, 9, and -4, -3. What is something that we learned about slopes of perpendicular lines? They are opposite reciprocals of each other. Very good. So what I'm going to do is I'm going to find the slope of this original line, and then I'm going to take the opposite reciprocal of that and use that for the slope of this line. Okay? So if I go y2, 9, minus y1, -3, divided by x2, which is 2, minus x1, which is -4, that will give me 12 over 6, or 2. So if the slope of my original segment is 2, what is the slope of the perpendicular bisector? -1/2. Whoops. Okay? All right, and then unfortunately this one right here, it's not clear where it crosses the y-axis. Just hang with me for just about 30 seconds more, okay? So what we're going to do is we're going to use this point right here to figure out where it would cross. What are the coordinates of that point right there? Can you see from the graph?
1, 2, 3,
3 up.
1.
Okay, so -1, 3. Okay? So if you don't know the y-intercept, you maybe will remember this from algebra. I'm going to take my equation y equals mx plus b. I'm going to plug in this 3 for the y. I'm going to plug in the -1/2 for the m, -1 for the x, and then solve it for b. Okay? So I'm going to rewrite this as 3 equals -1/2, because that's the slope, times -1, because that's the x-coordinate, plus b. Okay? What's -1/2 times -1? Negative times a negative is a positive, so it's going to be +1/2. How do I solve that for b?
Divide by 1.
No.
Times.
No. No.
Multiply by 2.
No.
Subtract 1/2.
Subtract 1/2. This is 1/2 is being added to the b, so I need to do the opposite of that, which is subtracting. So those cancel, and b is 2.5. So now that I know what the slope is, and I know what the y-intercept is, I can take and write an equation for that line, and it will be y equals
-1/2
-1/2 x plus 2.5. Okay? And this looks like about 2.5, and so that's good confirmation that we did our math correctly. Okay? All right, so short assignment for the weekend. Tanner, what do you need?
It was about that sun.
About what?
It was about that.
Oh, sorry, which one?
Yeah, that.
Okay.
It's like, you go 6 and over 3.
Uh-huh.
Just the opposite. Below that.
Right.
That.
Yep. If they give you the graph, then you can use the graph to figure it out. And that's what Laura said on the first one. She said, maybe just count. Okay. So if they give you the graph, you can do it that way. Absolutely.